Your phone lights up with a name you weren't expecting, and before you've consciously registered a single thought about what that might mean, your heart has already picked up its pace. Ask yourself, honestly, which came first, the feeling of unease or the faster heartbeat? Most people assume the feeling comes first, and the body simply follows along a moment later, obediently reacting to an emotion your mind has already decided on. The actual order of events is stranger than that, and it may change how you think about what anxiety even is.
Here is the claim we're going to walk through carefully today, because it sounds almost backwards at first. Your heart can start racing before the part of your brain responsible for consciously recognizing "I'm anxious" has even finished processing the situation. Not by a large margin, we're talking about a fraction of a second. But that fraction of a second is doing something genuinely strange. It suggests your racing heart isn't only a symptom of anxiety. It might be one of the ingredients your brain uses to build the feeling of anxiety in the first place. To see how that's possible, we need to follow two separate roads a threat signal can travel through your brain, and one of them is dramatically faster than the other. When something in your environment might be a threat, an unexpected name on your phone, a sudden sound, a stranger's raised voice, the sensory information about it first passes through a small relay structure deep in your brain called the thalamus. From there, it has two possible routes. Neuroscientist Joseph LeDoux, whose research helped map this system in detail, described them as the low road and the high road.
Piece 1. The high road sends the signal up to your cortex, the outer layer of your brain responsible for detailed, conscious analysis. This route is thorough. It builds a full, accurate picture of exactly what's happening, considers context, and eventually delivers a considered, conscious interpretation. It's also, relatively speaking, slow, taking on the order of a few hundred milliseconds to fully complete. Piece 2, the low road, skips that detailed analysis entirely. It runs directly from the thalamus to the amygdala, your brain's fast threat detection center, bypassing the cortex almost completely. It's crude. It can't tell you exactly what's happening, only that something might resemble a threat, based on very basic features. But it's remarkably fast, capable of triggering a response in a fraction of the time the high road needs. The moment your amygdala receives that low-road signal, it doesn't wait for confirmation from the slower, more careful cortical route. It immediately signals your hypothalamus, which activates your sympathetic nervous system, which triggers your adrenal glands to release adrenaline into your bloodstream, all of it reaching your heart and accelerating it within roughly a second or two of the original trigger. Piece 3. Your heart, in other words, can already be speeding up, while the high road is still somewhere in the middle of carefully figuring out what's actually going on. So the sequence, in the earliest moments of a potential threat, looks like this. A crude, fast signal reaches the amygdala and triggers a racing heart, while a slower, more careful signal is still traveling toward full conscious awareness in the cortex. For a brief window, genuinely measured in a fraction of a second, but real, your body is already reacting before your conscious mind has caught up with why. That much is well established, but it still leaves an open question. Once your conscious mind does catch up, where does the actual felt experience of anxiety come from? Is it purely a thought, generated independently in the cortex? Or does that racing heart play an active role in producing the feeling itself? To answer that, we need to travel to a different part of the brain entirely, a region called the insula, folded deep within the lateral surface of your cortex, and specifically its anterior portion, near the front. The insula is one of the brain's main hubs for something called interoception, your brain's ongoing sense of the internal state of your own body. Heart rate, breathing, gut sensations, muscle tension. Signals from all of these travel back up toward the insula continuously, largely outside conscious awareness, forming a constantly updated internal status report. Piece 4, and the actual reveal of this story. Neuroscientist A.D. Craig and others have argued that the anterior insula doesn't just passively monitor these bodily signals. It plays an active role in constructing what you consciously feel as an emotion. Modern affective neuroscience, including work by researchers like Lisa Feldman Barrett, has extended this idea further. Emotions aren't simply pre-packaged mental states that then cause bodily reactions. They're actively built, in the moment, partly out of the very bodily signals, heart rate, breathing, tension, arriving from the body itself. Which means the faster heartbeat, triggered seconds earlier by the low-road amygdala response, isn't necessarily just an after-effect of anxiety. It may be one of the raw materials your brain is actively using to construct the conscious feeling of anxiety, as that feeling is still being assembled. Put the pieces together, and the order of events looks almost inverted from how most people describe it. A crude, fast, pre-conscious threat signal reaches your amygdala and speeds up your heart. That faster heartbeat is detected by interoceptive pathways and relayed to your insula. Around the same time, or slightly after, your cortex finishes its slower, more detailed analysis of the situation. And your brain, drawing on both the cortical analysis and the already elevated heart rate arriving from your body, constructs the conscious experience you'll go on to describe, after the fact, as simply feeling anxious. The heartbeat isn't trailing behind the emotion. In a very real sense, it helped write it. This is genuinely different from the older, simpler idea that a feeling occurs first, entirely in the mind, and the body merely follows. It's closer to an idea proposed over a century ago by psychologist William James and physiologist Carl Lang, working independently, sometimes called the James-Lang theory, suggesting bodily reactions come first and the felt emotion follows partly from noticing them. That theory was considered too simple on its own for decades, but the modern interoception research we've just walked through gives it a more precise, more biologically grounded update. Not that the body causes the entire emotion by itself, but that bodily signals are a real active ingredient the brain uses when constructing what an emotion actually feels like. None of this means every racing heart signals real danger, or that this mechanism works identically for everyone. Individual differences in interoceptive sensitivity, baseline anxiety, and general health all shape how strongly this loop plays out, and a racing heart that's frequent, severe, or unexplained by an obvious trigger is worth discussing with a doctor, rather than assuming it's simply this mechanism. But for the ordinary version, the heart that picks up its pace a half second before an uneasy feeling fully lands, triggered by something as small as an unexpected name on a screen, the evidence points toward a genuinely two-way relationship. Not just a mind causing a racing heart, but a racing heart quietly helping shape the mind's own experience of anxiety in real time. Somewhere right now, a phone is lighting up with an unexpected name, and a heart is already beginning to race, a fraction of a second before the person holding it could tell you why. They'll describe it afterward as a feeling that came first, and a body that simply followed. The two roads inside their brain tell a more complicated story. The body got there first, and by the time the feeling arrived, the heartbeat had already become part of it.